Okay, today we're going to talk about the last section of this chapter, 9.5, rational equations. Um, Now, one of the things that you need to do when you're solving these rational equations is you need to look for restrictions. Remember, we talked about that a long time ago, or not a long time ago, but beginning of the chapter. And the whole point of that in the very beginning of the chapter was to set yourself up for this part. And that is, whenever you have, remember, variables in the denominator of a fraction, then there's a possibility for restrictions, meaning numbers that you could not use to plug back in and see if it worked. So impossible solutions, if you will. So when we go through and do this, we're going to do two things. One is we're just going to simply come up with our restrictions, and then we're just going to solve. So let's start with restrictions. So on the first one, remember the way you do it is you simply take whatever part that has the variable in the bottom. So that would be this part. And so it's just x, and you set it not equal to 0. Well, that was easy. There you go. There's your restriction. So if you get an answer that says x is 0, that's bad. Can't use it. So this is telling us that our answer can be, well, we don't know what it is yet, but what we do know is that it cannot be 0. So let's come back to how do I solve? Well, the way you solve these, and this goes back to something you learned a while back, or the easiest way is to just simply do some fraction busters. So figure out or look at your denominators and come up with the least common denominator amongst all of them, and then multiply everything by that. So as I look at x, 4, and 2, I know that the least common denominator is 4x. So I'm actually going to multiply everything by 4x on this side, and everything by 4x on this side. Now since I'm multiplying both sides by that, that's okay, keeps the equation balanced. Now over here you have to distribute. So I'm going to distribute that in. And what happens when I multiply 4x times this? Well, the x's will cancel, and I end up just getting 48. And what happens when I multiply the 4x times this? Well, this time the 4's cancel, and I'm left with 3x. And over here, 2 will go into 4 twice, and then 2x times 3 is 6x. And so what we have here is what we wanted, and that is to have no more fractions. So now we're just going to go through and solve. So subtract 3x on both sides. I end up getting 48 equals 3x. Divide by 3, and x is equal to 16. So if we're going to put this in solution sets, we'd say all values of x such that x is equal to 16. Now, is 16 part of our restriction? Nope, it's not. Our restriction was x couldn't be 0, so we're good with that. Okay, simple as that. So you have to check your restrictions, and then you have to solve. How do I solve? Well, I look at my denominators, I come up with the common denominator, or least common denominator, and I multiply everything by that. And if I did that correctly, or if I picked the correct common denominator, or least common denominator, then I shouldn't have any more fractions after that first step. And then I just simply solve. Okay, let's try another one. This time we have binomials as our denominators here. Well, what's the common denominator here? Well, it is x minus 5. Well, let me back up a little bit. Let's start with the restriction. Okay, that's what we did last time, so let's stay consistent here. So my restriction. Okay, so again, you would take every denominator that has a variable in it and set it not equal to 0. Well, these are the same, so we only have to do it once. So x minus 5 can't equal 0. So x can't equal 5. Okay, so I don't know what the answer is right now, but what I do know is that it cannot be 5. So let's solve. Again, I'm going to multiply everything by the common denominator. The common denominator is x minus 5. Okay, so when I do that over here, these will reduce, or they'll cancel, pardon me, and I just get 5. When I distribute this into here, the x minus 5's will cancel, and I just get x. When I multiply it here, I get negative 1 times x minus 5. So let's simplify that a little bit. 5 equals x minus x plus 5. Notice the x's go away, and I get 5 equals 5. Well, what does that mean? Well, remember that means if I get my variables to cancel and I get a true statement like 5 equals 5, 9 equals 9, 0 equals 0. Well, that's telling me that I'm going to have an infinite amount of solutions. Anything I want to pick will work. However, we do have a restriction. It says x can't be 5. So what does that mean? Well, that is telling us that we're going to have all my answers are going to be all real solutions except x equals 5. Okay, simple as that. So I can pick any answer I want, any number I want, fraction, decimal, whole number, whatever. Okay, all of them will work except for 5. Okay, and that's where that restriction comes in handy. Sometimes it doesn't come in handy at all, like on the first one, but other times it does, like on this one. Okay, let's try another one here. Let's see here. How about, let's just try this one right here for now. We actually might skip the fourth one. Let's see how this one goes. So let's look. I see some denominators here. This. Now, here's a big mistake a lot of times people make. And they say, oh, well, two different denominators, so I'm going to multiply everything by whatever the denominators are. And then they get some really big, complicated fraction. Well, just like section 9.4 when we were adding and subtracting rational expressions, we want to factor. So let's factor. And you notice that now this and this have a common factor. Now, remember the 4 has a denominator also. It's a 1, but we're not overly concerned about the fact that it has a 1. So what do I need to do to get common denominators? Well, since this already has an x minus 3, then what we need to do is we're going to have to go through and multiply everything by the biggest or the least common denominator. Well, the least common denominator would be x minus 3x plus 1. So we're going to multiply everything by that. Okay, even over here. And once again, if you do that correctly, you pick the correct least common denominator, then you shouldn't have any fractions left. So let's take a look. So you notice here these would go away, and I'm left with x plus 1, x plus 1. Now I do know, and I just realized I didn't do this, as I did not do my restriction. So we'll have to come back and do that here in a minute. When I distribute this, so I'm going to get 4 times x minus 3, x plus 1. Distribute to here. The nice thing is all that goes away, and I'm just left with minus 12. All right, so we got a lot of simplifying here. So if I go through and FOIL all that, I get x squared plus 2x plus 1. And if I go through and simplify all that, okay, including multiply by the 4, I'm going to skip a step here. You can write it out to prove it to yourself. You get this. Okay, so this comes from foiling this and multiplying the 4 in after I'm done foiling. So let's do some more simplifying. Let's move everything to one side. So if I subtract the x squared, subtract the 2x, subtract the 1, do all that simplifying, I end up with 0 equals 3x squared minus 10x minus 25. Okay, now I wouldn't expect you to be able to do all that in your head necessarily, but I had the benefit of actually knowing what the answer is, so no big deal there. So let's go through and simplify some more. We got to find out what x is. So hopefully it factors. If it doesn't factor, then that means you have to do a little quadratic formula or complete the square or something like that. Lucky for us, it does factor. So we get 0 equals, and this factors to be 3x plus 5 and x minus 5. Okay, that works out really nice. So, zero product property tells us this, 3x plus 5 equals 0, and x minus 5 equals 0. So x is equal to negative 5 over 3, and x is equal to 5. All right, those are our two possible solutions. Now, the problem that we have at this moment is we never figured out what our restrictions are. So those might be one of our restrictions, and if that were the case, we'd have to throw it out. So let's do that real quick. So we said to figure out our restrictions, we're going to take whatever is on the bottom, okay, that has a variable in it. So that's this x minus 3. We're going to set that not equal to 0. So that means x can't be 3. There's one restriction. Lucky for us, that doesn't come into play. And then we have this one over here. So now you can either do this, or you can just do the factored part. I think the factored part obviously would be easier. So that could not be 0. My marker's dying, sorry. So 0 product property, so that means x minus 3 can't be 0, and x plus 1 can't be 0. So my restriction, here's another one that says x can't be 3. We already knew that. And then this one says x can't be negative 1. So none of that comes into play. So here are our solutions. Again, if you want to put in solution sets, you can simply just say all values of x such that x is equal to negative 5/3 and 5. And there you go. The fourth example we'll just skip for now. We'll go through it in class. But hopefully you get the basic idea. The basic idea is you need to first, or you need to sometimes figure out what your restrictions are. Make sure you know what the answer can't be, and then you need to go through and solve. And the way you solve, or at least I think the easiest way to solve, is to go through and do some fraction busters. And the way you do that is simply look at your common denominators, okay, whatever they may be, and simply multiply by whatever that least common denominator is. So, as always, if you had some questions or you didn't understand something that I did, write those down or make a little note to yourself, and then we'll talk about it in class. All right, thank you.